Hello there! Today I'm going to attempt to start explaining chemistry. Why? I love chemistry and it's a beautiful subject. First, we're going to look at atoms. They are made of protons, neutrons and electrons, but you may or may not have heard of this already. But we need to go over this, otherwise this video will be as effective as doxing a homeless person. Let's start with protons. Protons are small, positive particles, yeah, that will do for now. The number of protons that an atom has decides which species of atom it is. 1 proton, that's hydrogen. 8 protons, that's always oxygen. Look at the periodic table. You read it from left to right, top to bottom, as if it was a book. With each step, the amount of protons increases. You cannot change the amount of protons in an atom. Well, you can, but you might get some trouble with the United Nations. The amount of neutrons, however, can be different. These neutral particles can differ between atoms within the same atom species. Hydrogen can have 0 neutrons, as it most often does. It can also have 1 or even 2 neutrons. A prime example would be uranium. Uranium-235 has 3 neutrons less than uranium-238. But this difference is what makes it useful to get into trouble with UN. If 2 atoms are in the same species but have different amount of neutrons, they are called isotopes. Protons and neutrons together form the core of an atom. The core is surrounded by the electrons. Protons and neutrons have basically the same mass, but the electrons are a lot smaller and their weight is negligible. But their negative charge is not. It is the same charge as that of protons, but negative. So the positive charge of 1 proton is cancelled out by the negative charge of an electron. A neutral atom has 1 electron for every neutron it has, and electrons are the particles of the atom that actually do the most stuff during a chemical reaction. Not all atoms are neutral. When a sodium atom meets a chloride atom, the sodium atom gives 1 of its electrons to the chloride atom. Sodium was neutral, gives 1 negative particle to chloride and becomes positively charged. Chloride, which was neutral, picks up the negative particle and becomes positively charged. From then on, they are called ions. Cations are positive, anions are negative. And as if it were a wedding ring, they will stay together because positive and negative attract each other. This is called an ionic bond and is solely based off of charge. Positive and negative ions will surround each other like this image. This is called an ion lattice. If the atoms are moved just a bit, the pattern will break, because positive atoms repel each other and negative atoms repel each other as well. I want to make a joke about marriage, but low-hanging fruit is often already half eaten, so just pretend I said something funny instead. Atoms can also form bonds between atoms of the same species. This is called an elemental bond. A species of atom is called an element. I should probably have said that earlier. Anyway, the atoms will both share 1 or more electrons to form an atomic bond. I will explain why in some other time. And lastly, atoms can also form bonds between atoms of other species, which is called a molecular bond and is formed between non-metals such as chloride, carbon or hydrogen, sulfur, nitrogen. It's similar to the elemental bonds, but we'll look at those later as well. Metallic elements can also be ordered in lattices, but the electrons will move freely throughout the lattice. This is why metal can transfer electricity. If you put a big atom in a lattice of smaller metallic atoms, the bigger atoms will give the lattice more irregularities. This makes the metal less bendable, but more easy to break. Next time I will try and explain why atoms react and we'll mainly look at the electrons. I think might change. This probably was not a lot of new info, but trust me, if this series keeps going, it will be necessary. Anyway, that's it for today. I hope you learned something or at least enjoyed yourself.